Welcome to the Retro21 Studios podcast. I'm your host, 𝐼². Today, I'm joined with George Earle. George is Chief Growth Officer at Praxie, Inc. How are you today, George?
Very good. How are you?
I'm doing well. It's a pleasure for you to hop on. We obviously have some history. We're colleagues in the not too distant past, so it's really good to have you on today.
Thank you.
Awesome. So this is part of the brand storytelling series on the Retro21 Studios podcast. Can you tell us about yourself and Praxie? What's Praxie's mission and focus around artificial intelligence?
Sure. Electrical engineering background, have a little gray hair. So my first neural network project actually was in the late 80s. And interestingly, it was around resource allocation. We were in the defense world at that time, so it's not completely applicable to now, but the mathematics is the same. So if you are trying to do just in time well, and you're having issues with your vendors, that's the sort of NP complete problem that you run into. The interesting thing about AI now is that large language models can do machine learning activities and tasks, and you don't have to decide which of the machine learning algorithms to use. So we're experimenting with that. I spent half of the beginning of my career in the computer industry, actually building hardware at computer companies that are no longer with us. And then I moved into enterprise software, and I've spent the last 20 plus years in different enterprise software companies. So I'm sort of a serial entrepreneur currently living in Texas.
Excellent. So how did you come across Praxie?
So when you're in the enterprise software space, you tend to work with the same colleagues. So my boss, the CEO, is the same person I worked with in 2005. And we both sold a company to SAP. And now we're back with another enterprise software company. So I'm working with the same person I've known for 20 years.
Awesome. So what is the gist of Praxie? Do you guys produce one product? Do you have a series of products?
The start of the whole company, as Michael says, is when we were both at SAP, he was running the IoT business there. And unlike the financial industry, which is very digitized, very real time, makes the best use of most of the new technology and networking and everything. You go into a lot of manufacturing plants, and although the products like the cars, planes, jet planes have a lot of technology, manufacturing itself is still doing a lot of things with paper and spreadsheets, electronic paper. We have a platform that allows us to build things quickly, rapid application development, but it's built on technology that looks more like what Google has. It's a NoSQL Elasticsearch oriented event stream architecture. It allows you to build things without having to worry about the database design structure and foreign keys and all that stuff. So we can build things 10 times faster and therefore 1/10 the cost. And we are doing this because we feel there's a gap in the world, which is you have large costs to build big solutions, or you buy a big expensive solution. Therefore, you have very limited finances left to attack all of the problems that just are attackable by enterprise software, but you can't build it all because it costs too much to build. So we're trying to fill that gap where you can build things quickly, but they're enterprise scale. They run on the Google Cloud, so they're accessible everywhere and don't have any of those issues that you would have if you were trying to build your own little private little app on a small computer in the back office.
George, thanks for providing that perspective. Praxie, who are some of your customers, and is there a particular use case that comes to mind that could help put more context around what you guys do?
Sure. There are a couple that I can mention because they're public. One is called 𝒂𝒄𝒊𝒂. It's a manufacturing company that makes steel tubing and lots of associated products. Another company is a big retail organization. And I picked these two because they're kind of widely differing in their digitization challenge. The retail company has lots of locations. They need to standardize a lot of their practices across all of those stores so they can have consistency. And we help them with doing digitization of the process of approving things that go into the stores, as well as processes that the people use. At AccuTube, one of our more dramatic ROI, because we help them pay off the system from an ROI point of view in only about 4 months. And that was more of a digitization of a huddle board thing, which is if you walk into a plant, sort of like what you might see in a customer service environment where you know how many seconds every call is taking, how long people have been on hold in a manufacturing plant. You want to know what products do you need to build, how many things you're building today, how long has it been since the safety incident. And a lot of that is still done with paper, pencil, and dry erase markers on whiteboard. So if you digitize that, you can pull in all the order information from Oracle or SAP in real time. You can deal with your incidents in real time, decide what you need to do from a maintenance point of view, what machines the mechanics need to attack because it's affecting production. And those are sort of the two dramatic areas that we're helping to digitize and get out of what we call electronic paper.
Got it. So if you were describing that particular use case, right, in the context of these two organizations, I'm sensing lean manufacturing, right? Some lean processes, time, efficiency management or optimization.
Yes, we are, and a couple of customers have volunteered this. We're kind of like a manufacturing operating system. If you look at lean engineering, Six Sigma processes, a whole black belt training regimen, there are about 100+ different tools that you can use. And most of those tools are in Microsoft Office tools, right? There are PowerPoints, there are spreadsheets, and therefore, especially the ones that are in spreadsheets, that means there's mathematics associated with some of these things. But where do you get the data from? The data comes from either people typing it in, or it comes from the systems that they've exported data from. All of that is enterprise information, but now the data has been sequestered into all these tools. We help bring that data back into an enterprise so databases can be accessed. You can query these systems.
So with the system, so you mentioned a lot of what you describe is in the Microsoft realm, right? The spreadsheets and that sort of thing. So if I was an organization wanting to make a transition, bring on Praxie, how would that happen? Would we just have to start from scratch? Is there a way that we could port this information into the tool? Can you describe that in more detail?
Sure. So let's say there's primarily 3 ways to get information, and we can connect directly through 3 interfaces that are popular to machines using MQTT, to enterprise software systems through RESTful interfaces, or SQL databases that may be out there, such as in Oracle or Snowflake, things like that. So that's an electronic way. Obviously, you can type into it. But an interesting thing that is also part of the whole speed part of our development is that companies are using spreadsheets to enter information. So let's say, take something easy like the end of shift need. How many things did you produce? How many pieces of scrap did you produce? And people will collect information. Sometimes there'll be displays from some of the machines, but then they type it into a spreadsheet. We've seen people do things from a range of printing the spreadsheet and then stacking them up to the end of the week. And then somebody creates a summary spreadsheet by looking at all the spreadsheets and typing information in. We have the ability to take that spreadsheet right into our user interface. We don't have Excel running, but it is a spreadsheet widget. And the look of the spreadsheet is exactly how it looks in Excel. Mm-hmm. Therefore, we can start people with where they are. So if all the team leaders that are on the floor are using this spreadsheet, they've worked out the formulas, all the mathematics work, this formatting and the shading works, it'll look the same inside of our application. All they have to do is learn how to log in. They start typing into that spreadsheet, but now through data linking, that looks a little bit like the data linking you do in Microsoft Power BI. All that data is now in an enterprise data system that's accessible through queries and other tools. So you can type data into forms, into screens. You can use Excel spreadsheets that have data, and you can upload the spreadsheet data itself as a data set, or you can use the spreadsheet as a user interface, and we can connect to external systems using the 3 integration methods I've said.
Excellent. Now, is there a generative AI or some AI component under the hood?
So yes, that's the biggest thing that's happening, obviously, in the IT world. We're very excited about that. We use the enterprise version from Google, Vertex. So it comes with all the benefits of being enterprise. So there's no saving of the data that we send it. to the back end. Security and encryption capabilities of GCP is involved with that product. If you have any proprietary data that is being analyzed, it's not going to be shared with the rest of the world. It's in your private space. What we're doing that is very different is most people are interacting with AI right now through a chat bot, and they're starting to learn. You've got to spend a lot of energy and effort giving it information, telling it what you want, telling whether the output is correct. Well, because we have a well-known domain, we're in, let's say, manufacturing, and we're in lean engineering or in supply chain or the other use cases, we know what we're looking for, we know what we want. So we actually embed the AI as kind of an engine. The data that's coming into our system, we send that without the user having to be involved. So we have two applications. One will be an AI application, and then there'll be a non-AI version of the application. So let's say we're doing a gimbal walk, which is the ability to walk around a plant, find out what's wrong with some of the machines. Normally, some people will write that on a notepad. So in our app, you can record that, which can lead to a work order. But if AI is involved, AI can actually help generate the Q&A and the solution part of this process. So in a manual sense, you would take the gimbal walk data that you collected, maybe an hour or two later, you'd have a meeting with other mechanics or engineers, you'd have discussions, and you'd have to spend manual effort to ideate, figure out what could be going wrong. Hopefully people there have experienced those same problems before. Then you have to generate a plan to do something about it. We have integrated all those capabilities, and then you add AI. So now you have a gimbal walk application that has a button that says generate possible problems. That could be the root cause of what we saw. Generate solution ideas. Generate an action plan based on those solution ideas. Put those action plan ideas, which are bullet points, into a Microsoft-looking project plan, into a Gantt chart. So we're using AI to enhance all of our applications, to make them more informative, to generate ideas that are context sensitive without having any of the work of prompt engineering having to be done by our users.
That's awesome. And I know we talked a little bit earlier around the accuracy of the bot, right, of generative AI. And we talked about hallucinations, and you were mentioning something that you guys want a little bit of hallucination, right? That fits into your use case. Can you elaborate on that?
So, yeah, I get a kick out of that word. Hallucination in a person is idea generation. The difference between hallucinating and coming up with ideas is the hallucinations are not grounded in physics or reality. They're not applicable, or they're too wild. They're not bound by the problem space, right? Well, you take care of that with prompt engineering. But since we're using our context to narrow the focus of the AI, we tell the AI, this is the context of the information we're going to give you. It's actually pretty long in that sense from a prompt point of view. So we bound it that it's in manufacturing. We bound it with the type of information we're going to give it. Since we develop the prompts that are in the application, we know exactly what all the data entry is going to be. We're going to give you a problem. We're going to delineate all the issues. We're going to ask you for a to-do list. So we're giving it much more context. So when it does start to generate the ideas are within all that context, and the hallucination, the idea generation is completely appropriate. The tools now do a good job of giving you references about where they may have pulled some of their conclusions. So there's referenceability inside of all of these responses that we're getting. So we don't have any issues with the non-productive hallucination.
So from a persona perspective, how would you approach each one, right? From a Praxie perspective, they're both manufacturers. The one, they've been in business for a while. Practices are kind of routine, but they're not really following hardcore lean. And, they know that they probably could be more efficient, right? They're okay. And the other persona is organization X and Y. And this organization does in fact have lean processes in place. However, they're looking to modernize their approach. So can you describe how you would handle both of those?
This is a sales challenge that every company has. We find that people that are the most eager find us. The entities where we have to find them, yes, we run into those two different types of companies. So the formal one is harder because they haven't even decided that lean is useful. So you kind of have to tell them, about Six Sigma, why 99.59 is important, because if you don't have that much quality, you're producing so many defective things, you're having to repair all that in final QA, all your profit goes out the window. So usually we try to deal with sort of the base reasons why lean engineering and Six Sigma are important from a financial point of view. 99.999% perfection, it has to be automated. Your measurements have to be automated. Your understanding of problem and solution management has to be automated, or you will get overwhelmed by all the problems that occur. And the second one, where they actually are doing lean, and we have a couple of customers like this, the continuous improvement group is, because the entity is performing all these, we're using electronic paper tools, Google Sheets or Excel. They're starting to get overwhelmed by paper. And if they've been doing it for a while, they now have a lot of material that they are trying to distill over time to produce trend charts. So one of the more important charts is the SPC chart, the statistical process control chart, that says something is bouncing out of range, right? Well, in order to have a chart like that, you have to have a lot of that data. So now they have the whole digitization problem. Well, how many spreadsheets are you able to consume at once? Do you have 52 spreadsheets for a year? Are you able to handle all that? So when we get customers who are recognizing that burden, it's easier to sell to. Otherwise, we have to convince them to think about the burden of the scale of that. What we've noticed is they can still handle all this manually. And I would say that's a plant in the $10 million a year range, revenue-wise. Once they get to the tens of hundreds, like 1,000, 2,000, 10,000 or more, then they're going to start running into these issues where they can't scale. The processes get out of control. The quality then suffers, and they're running after their tail, as they say, with trying to understand why the machines are out of control, why they produce a lot of bad parts, and they either have to raise their prices to accommodate all the scrap they're creating, which then allows competitors to come in who are more efficient, or they're trying to reduce their prices and become more efficient, and they're running up against the problem of not automating, and they can't squeeze that anymore.
Got it. Is there any what if scenarios that you could run within the tool, right? It sounds like there's a lot of intelligence under the hood. Can you do predictive activities, right? So say you gather the data that you just described and you want to do some sort of forecasting or what if analysis. Are those capabilities in there? And what would that look like?
Yeah, so we have two good examples of that run right now. One is predictive maintenance, and we're using a partner for that because they've gotten very good at the whole vibration analysis, and it's a self-learning system. The second idea that we are developing is what we call intelligent operations. So we've created an intelligent operations application, and it's a multi-step application. And I'll try to simplify it. But basically, there's an ingestion of data. There's an analysis of information by the LLM. It then produces questions because we're prompting it, right? So one of the first things we ask it to do is look at this data set, and we say, what questions can you generate from the data that we have given you? And it will then generate questions that have to do with patterns that it has seen. And then we allow through, an open text window for the person to add more questions to it. Now, why the solutions and ideas are interesting is that we then have a second phase of the application where we generate a kind of a Monte Carlo simulation of, okay, let's say we take one of these Q&As and we do this activity. We increase our prices by this much, or we decrease our costs, or we reduce scrap by this much. Over a year, it will help generate, kind of like in a Monte Carlo simulation, what would happen if it's a 5% reduction or a 5% increase? What will that change using the real data? Let's say it was an order stream or manufacturing stream of data that we gave it. What would happen over the next 12 months if those things happen? And it then graphs the improvement. And then because, it's a computer system, it can also calculate when does your ROI go from negative to positive.
Right.
And that is an amazing capability to be able to do that in one application, to take you from a set of data where you're not doing data science yourself. You're allowing the LLM to do data science, data analysis on a data set that you didn't have to massage. We're not normalizing the data. It actually can normalize the data. If it's, let's say, states that are inside the data, it knows that New York is the same as NY, or New York City is in New York. So we don't have to do a whole lot of data cleansing and data cleaning. And the reason that's powerful is we spend a lot of money on data cleaning because all of our mathematical algorithms require perfect data. We understand what fuzzy logic is, but fuzzy logic and a formula doesn't work too well. They have high error. You'll have bad data, erroneous data, the standard deviations will be too big. The LLM doesn't have a problem with that. And the ability to be able to generate a simulated run of data on multiple questions is a huge improvement in the number of ways that you could do what-if analysis in a certain given amount of time. If you were to try to do this with people, it would take a lot of time to generate the Monte Carlo simulation, to run through a bunch of them. Then you'd have to take the output of that and take the real data and then start using the numbers from both of those things to come up with a simulation of, well, what would the profit and loss look like for the next 12 months? And then you'd have to run it. If you try to even create an application, it would be a very rigid application because it would be attacking, let's say, one problem space. Whereas this intelligent operations application is problem space agnostic, because you're telling it, I'm giving you order information, or I'm giving you heating and cooling from an oven pasteurization process. And that's enough for it to guide it in its data analysis. So that's an application we're very proud of that we're creating right now.
I'm curious, you mentioned a trigger. So ROI hits a certain trigger. From a information radiation perspective, how is that happening? Is it when I pull up a report? Do I have a visualization, a dashboard? How does that work?
So it can be operated in a dashboard sense that you can set up, think of the application as a template. You then push a button to create a copy of that template. And then you connect that particular copy to a set of data streams. Let's say you produce that data stream every day as a batch output to start with. Well, then now with the Q&A and the other information you type in about the problem space and other things, you now have a templated application for your order history. So every day you get new order history because you can upload from your cash register terminals or whatever, the new order data. So that means you can turn this intelligent operations application into a dashboard that's one of our interfaces looks like a Kanban card. So you'd see today's date, and you'd see intelligent operations applet running there. And if you touch it, it will open up and expand, and the data that you see there and the Q&A and the simulation would be for today. So you could keep this going just for the retail operations today. Then you could create another analysis that has to do with vendor incoming purchase orders and ship dates that you might need for your just-in-time supply chain. Am I going to be able to keep running production and match my orders, or is something going on in my supply chain that I'm going to run out of parts in 2 days? This system will allow you to simulate what would happen if that snowstorm or that hurricane that's coming actually happens before it happens. Simulate which one of your vendors is the most at risk. Think about if you have a company that has 1,000 vendors to make a car or something like that, constantly doing this analysis will be an issue, because you're probably waiting for the signal to come from the vendor telling you you're going to be late. And if you tried with human beings to simulate, well, which one of these vendors that are in the Midwest are going to get hit by a snowstorm or a tornado, it would be a combinatorial problem. LLMs don't seem to have an issue handling at the moment. because you can narrow down the scope, and it will generate some thoughts about which vendors are going to be a problem. You take those vendors and then you run it through the rest of the part that simulates the problem. And now you have an ability to tackle the issue that you might have. You might be able to buy more expensive parts from a part of the country that is not going to have any weather, and you will pay more. But it's not as much as losing production, because the one that is closer can't ship to you at all. And now you have a whole lot of products in the warehouse, and your warehouse is filling up and you can't finish them.
So let's switch gears and let's talk integrations. We talked earlier about tool setup, right? Microsoft Office Suite and just integration with some of the Office type products, those productivity tools. Now on the manufacturing side, you mentioned the pasteurization example, a pasteurization plant, temperature, gradient change, that sort of thing. So if we start talking in terms of IoT, maybe that firm is capturing that data, right? Temperature has to be X over a certain period of time. If there's a certain fluctuation, there's some risk. And so that triggers something, right? So that's change data capture. How do you guys integrate with some of those, say, if they're using a CDC tool like Debezium or something like that?
Commonly what we found is that the companies have either created, or there is an Oracle database, MySQL, whatever database that is being filled with that data.
Yep.
And maybe it's a historian, and the historian is receiving millisecond data, but then they pull 1 minute data from the historian. So there's a database somewhere. The MQT data stream is also available to us, but that can get unwieldy if you don't have a historian around. So let's say you have a historian and you have a database attached to that. We can pull, or we can be pushed data through a webhook every minute. Now, once that data starts to stream into our system, we have a workflow system where we can set up. The data will stream into one of our data components. And on that data component will be a rule that says, if this cell, let's just call it a cell for now, this number goes above 100, then we are going to attach a workflow to that. That workflow can do lots of different things in our system. It can pop a window, and on that window is a pre-written email about the particular data or characteristic that went over. And then we auto-write the email. We automatically put in who it needs to be sent to. Let's say the plant manager. That screen shows up maybe on whoever the team lead is, who's looking at our operations console. On the other side of the screen, because we know which data went over, we automatically search whatever their document management system is for that particular asset, for that particular problem, and we tell them which document you need to look in for that particular temperature going over. So we do multi-system access to bring context to the people based on this trigger, because we have a workflow system that can be integrated with multiple systems. And then the last thing can be, if this problem is determined to be serious enough, there's a button where we can create a maintenance ticket to allow the maintenance team to look at whether this is a work order issue, or they can click the work order issue and immediately start a work order process. Because of our integration to a system, let's say is SAP, we can then go back into SAP and create the work order in there for the final system.
Awesome. So if I'm a manufacturer, I'm wanting to step up my game because of competitive pressures or just continuous improvement, how would I go about getting in touch with Praxie?
So the easiest thing, obviously, is to go to praxie.com. You're going to see a nice, fancy website. It'll tell you some interesting bits about what I just said about ROI and AI and lean engineering. You'll see a pop-up that says, hey, do you want a demo? There's also a button that says, hey, would you like a demo? So if you click that, we'll get a message. You'll be able to schedule a time with us, and then we'll get on the phone call and discuss your problem space and what you may be looking for.
Awesome. George, I appreciate you sharing a bit of history and under the hood with respect to Praxie. I'd love an opportunity to bring you back on and we could actually walk through a particular use case or demo. I think that'd be awesome.
Yes, I would love to show you that.
Awesome. Well, again, thank you so much, George. Thanks for joining the Retro21 Studios podcast. I'm your host, 𝐼². Take care.